Hello guys, welcome to lecture 11. In this lecture I will cover rule-based system and action prediction. Now rule-based system is actually still a decision-making AI, and for rule-based system I do not change any slides from John C's previous slides, so you should find something very familiar there. I only add a few slides to add some examples for better explanation. And by right, actually this lecture is supposed to focus on probability, and I managed to find a very good lectures that uses probability in games, and that is actually called action prediction. So in this lecture we're going to have probably two videos. One video will we'll talk about rule-based system, which is this one, and the other one will be action prediction, which should come on the other videos. So without further ado, let us begin on rule-based systems, right? Okay. All right. So now let's move to the next slide. So this is the outline for this week's lecture. First, we'll cover rule-based system, and we're going to touch on the basics, look at one example, and then after that we'll talk about the difference between forward chaining and backward chaining. You will get to know about that in a moment. And after that we will talk about action prediction, where during lectures we will need you to review some of the set theories and probability theory, and then we'll give an example based on fighting games, those kind of Street Fighter games. Alright, so now we move on to the next slide. So rule-based system. So what is a rule-based system? Well, actually it is not much different from those that you have learned before, the finite state machines and decision tree. So what is the similarity? The similarity is that all of them are going to consist of this if-then or they call it if-else rules. Alright, so you have seen this before in decision trees and perhaps in fuzzy logic also. So you will see the same thing coming out again for rule-based AI. So in general, rule-based systems typically refers to all the AIs that has some kind of rules, if-then rules, like what we have seen before. But in these slides, when we talk about rule-based system, we basically refers to this thing called expert systems. Now, expert system is actually something that came out early 1980s, right? During that time where there was a system being developed to do a medical analysis and all other related tools, where expert systems becomes very, very useful. So then during that period, this rule-based AI becomes very popular, and it has been applied to many areas, which we'll see the examples now. So common usage and applications. So I mentioned medical diagnosis. So what these expert systems is used is basically, they actually create a kind of system where they ask for the patient about about their symptoms, of some disease symptoms, and then the system will actually try to guess what is the disease that the patients are actually currently facing. And for fraud protection, basically is to prevent from any frauds in the system. So this is more on the security side. So what's the advantage of an expert system? Well, basically it mimics the way people think and reason, and based on a set of known facts and knowledge. Okay, we'll go deep into what is expert system very soon. Okay. So now let's talk about rule-based system used in games. So why it can be used is useful because the knowledge encoded in the rules are modular. Modular in the sense that you can actually expand the rules easily. After all, they are just a bunch of if-then rules, so you can actually combine the conditions with many combinations, such as the logic operators that we've talked about before this. And you can actually encode the rules in any order, so it's very flexible. for you to modify the rules later on. So now let's look at an example of a rule-based system being used in games. So here comes a example which is used in the real-time strategy games. So what you're seeing here is actually an image that corresponds to a technology tree. So what is a technology tree? Well, those of you guys who have played RTS before, RTS like Warcraft and even Starcraft, you probably know that you can build a set of buildings, and different buildings depend on other buildings to exist first before you can build. There's some prerequisite systems whereas to what buildings you can build depending on what buildings is available. So this is one example of a graph showing the technology tree, where you can see here, for example, the peasants. Once you have the peasants, then you can build woodcutters, and then from there you can build stonemason. And once you have stonemason and woodcutter, then only you can build temples. And once you have temples, then only you can have priests, and the list just goes on. So this arrow is actually telling you that you can think of this arrow as is prerequisite of. So for example, this peasant is a prerequisite for a woodcutter, and the same goes to a stonemason. So you can actually interpret this tree this way. So all the links that you see here basically shows you how you can train your facilities and to build your resources, so that your territories can expand in the game, right? So now how is a rule-based system being used in this game? Well, suppose let's say the NPC is trying to you are playing with NPC, right? So this NPC, in order to know in order to strategize, you actually need to know your current state of the player, right? So the goal here is that the competent opponents actually try to understand or try to get to know what is the current state of technology, because by having this knowledge, then basically what can the AI do with this knowledge? Well, basically he can access, he actually sends scouts to collect information, actually decide what to do based on your current state. So for example, let's say he finds that you actually have lots of priests, for example, right? Just now we saw in the example, let's say you have priests. So when you find that you have priests, that means he can infer that you also would have temple, and knowing that you have a temple, then he will be able to infer that you have woodcutter and so on. So by having the NPCs, finding intels from your current state, then he'll be able to guess what to do. He probably would even be able to decide what buildings to build in order to counter the game entities that you have. So yeah, so this is basically one of the reasons why we would actually need a rule-based system for this. So yeah, so let's talk about the rule-based system basics. So basically any rule-based system we actually have two components. So the first component is called the working memory, and this working memory basically stores known facts and assertion made by the rules, right? So, and what is the rules? Well, basically rules are rules that you specify and it's stored in the rules memory, and it actually contains the then style rules that operate over the facts stored in the working memory. So you actually have two components, and they are working together. So the working memory actually usually stores what the AI already knows about the current state in the game, and then this working memory, the data in the working memory are actually used to actually check based on the rules that you have to determine whether certain things have happened, and then they will decide based on whether the condition of the rules is satisfied. So if the rules are satisfied, we call that as being triggered. Triggered means the condition of the if statement is true. So when it's true, then the actions of the if statements will be fired. So that's actually similar to FSMs and even DTs, right? Because they also have if-else statements, their rules. And the additional things that usually is only in rule-based expert system is that they not only do they actually able to do something when the condition is met, but rather they can also modify the contents of the working memory. For example, they can add new things, new information to the working memory. For example, let's say if in the case of RTS games, if they realize that the player has already have a priest, then they will actually add this information to the working memory. So the rules actually, if it's satisfied, it can possibly modify the working memory, unlike finite state machine or decision trees, which they usually didn't do that. So this is a sample working memory for the medieval games that the RTS games that we saw before this. So you can imagine it's just a bunch of variables storing information about whether the player has any of these units, right? So for example, so you can see here we have a bunch of T memory value, and what is that? It's actually just an enumeration that that supports yes, no, maybe, and unknown. So let's say if you can interpret it this way. Let's say if you have this variable peasants, and if it's assigned to the value unknown, it means that you do not know whether the peasant is already available or not. Or you probably if you assign to maybe, it means that you're guessing, yeah, maybe there's a chance that the peasant is already available. And if let's say these are all actually guessing kind of values. If you are sure, that means you will either choose a yes or no, saying that whether yes, you know whether there's a peasant, or no, whether there's no peasants. Yeah, so this is how actually this is the easiest way of what is inside working memory for the particular example. So computer can gather facts by sending out scouts to see if the player has built a temple, right? So for example, you can send a scout to see what the player has built, and after that they will actually they have rules that they have to follow. So once they follow rules, then they will know whether a certain state needs to be updated. For example, if you look at this rule right here, so here it says that if the woodcutter is yes and the stonemason is yes and the temple is unknown, then here the action is that the temple is assigned to maybe. Now what does that mean? Let's look back at the previous technology tree. So if you realize that if you go back to condition, you realize that the woodcutter, there is a woodcutter, and you realize that there's also a stonemason, then but we haven't seen whether there's a temple in the player's base, then you probably can say there's a chance that the temple is there, but maybe you didn't see it. So that's why it is assigned a maybe. So the meaning of this rule is to say that if you found that there's a woodcutter and there's a stonemason, so it is possible for the player to eventually build a temple later on, even though at this moment you do not know whether the temple is there or not. So you actually change your state to maybe. So this is one of the example of the rules for this particular game. So another way that you can see this rule-based system is that if let's say the player has observed to have a priest, then you can infer that player also must have a temple. So this is a backward kind of inference. So so here you look at this rule. It says that the priest is yes, then you want to infer that temple, barracks, woodcutter, and stonemason is equal to yes. And why is that the case? Let's go back to the table again. Alright. So let's say you see that there is a priest. Now, because priest, in order to have a priest, you need to have a temple and also a barrack. So you can actually go backward and infer that, oh, if I see a priest, then I actually can guess that temple is there, as well as the barrack. Now, if you know that temple is there, then there's a high chance that woodcutter and stonemason is there. So this one is kind of like a backward, backward way of inferring what has been built. Alright, so so for this short video, we will stop until here because the software that I'm using can only capture 15 minutes. In the next 15 minutes, we'll cover the remaining portion of the slides. So do check out later, right? Thank you very much.